Hello everyone, welcome back to my channel. So in this video we would be studying about process synchronization. So basically processes can be of two types. One independent and the other cooperative. So what we basically understand by cooperative is that one process might interact with other process, or one process might need the help or cooperation of some other process to work. Let's say for example we have two processes P1 and P2 and both of them have different variables. Let's say A, B, C, X, D, whatever, and let's say P2 has C, D, L, M, N. So we can see that C and D are common in both of these processes. So this might be possible that C and D are global variables which are being used by both of these processes. So basically let's say it also updates the values of C and D, and this process also updates the values of C and D in some manner. So they would need to cooperate with each other to know how has C and D been changed here and how has it been changed here. So let's see the examples of such case and what are the problems that we might face in such a case. So let's say we have two processes, process P1, process P2, and let's say that this is a function, let's say void take, and this is void give. So, and here what we do is that we do count plus plus, and here what we do is count minus minus. So every time you take something, your count of things increases, and every time you give something, the count decreases. So that's what these processes are doing. So basically these processes are not as simple as this. So if first of all count is a global variable. Now let's discuss about this. So basically inside the process, this doesn't run simply like this. What happens basically is that another variable is created. It happens like this: reg is equal to count, reg is equal to reg plus 1, and count is equal to reg. Similarly here it's like reg is equal to count, reg is equal to reg minus 1, and then again count is equal to reg. So what happens when we do this? Like let's say that the processes are in a round robin and the time quantum stops it here. So what happens if the time quantum stops this or preempts this process here? So let's say we had the value of count as something 3. So now reg has the value 4 and count hasn't been updated yet, and then it comes to give. So what happens here? Let's say this whole gets executed. So after that execution, since count was earlier 3, so here it will become 2, and when we come here, count is equal to reg and reg is 4, so count will become 4. So we have inconsistent values of count here. So this is a condition known as race condition. Let's understand race condition with the help of an example. So let's say we have a function f1 and a function f2. And let's say that x is a global variable. Earlier it was given equal to, let's say, 3, and we have been given if x equal to 3, y is equal to x multiplied by 6. and here we have x plus plus. Now let's say the function f1 got preempted at this point and x gets incremented, so what we get is that the value of x becomes 4, and here what it will do is that y will become 24. Rather, we wanted it to be 18, so this is 18. So this is also a race condition wherein we saw that the value of a variable that we wanted, we didn't get it as it. So there are several other problems that might arise due to race condition. So that's it in this video for race condition. In the next video we'll deal with a new topic.